just started up, and you can see there's a belt there which drives the pulley on the compressor. So this is the actual air conditioning compressor, and we're just going to turn the aircon on, and then once the aircon is then turned on, you can then see that the pistons inside the compressor are pumping, which will then compress the gas which is inside the system. So at this particular point, you can see here that we've got the gas is around about 0 degrees C, and you've got approximately 3 bar of pressure, which is roughly just over 30 psi. Just bear in mind that we are looking at a system where the outside temperature is 30 degrees. Generally, if you were going to do any testing on a system, you're probably going to find it's probably around about 21 to 25 degrees outside. Well, if you're here in the UK anyway. So just bear that in mind. The outside temperature does has a massive effect on the actual pressures. So once this compressed gas then is compressed by the compressor itself, it then starts to exit the compressor, and you can see now the gas has actually reached approximately 85 degrees C, and we've got around about 16 bar of pressure. So it's extremely hot gas, and around about 16 bar of pressure there. So roughly as I said, on a normal operating temperatures, you're probably looking anywhere between, on the high pressure side, you should have 10 to 15 bar of pressure, depending on what the outside temperature is. Again, this is 30 degrees outside. So between 10 to 15 bar, that's approximately 150 to about 210 psi. So once this gas now leaves the compressor, it makes its way over to the condenser, and it's also got a filter dryer there, or a dryer, which is built into the actual condenser itself. So as it kind of enters the top of the condenser, we can see that the temperatures are approximately still 85 degrees and around about 16 bar in pressure. Now the temperature drops as it goes through this condenser, which is a bit like your radiator. You can see that the temperature now drops right down to approximately 50 to 55 degrees. So we're still maintaining the same amount of pressure, but we can now see that we've actually turned our gas back into a liquid. That's due to the actual temperature change. So that's the whole point of the condenser. As I said, it's a bit like a radiator. It's just reducing the temperature to turn that gas back into a liquid. So once this liquid then will flow through the actual dryer, and the dryer is there to stop any gas continue through the system, because we don't want any more gas to continue through the system. It needs to be in liquid form. So it goes up through to the bulkhead, where it meets the thermal expansion valve. So this thermal expansion valve is kind of the halfway point of the system. So between the expansion valve and the actual compressor itself, you've kind of got two halves of the system. So on this particular side, which we've been looking at, is what's known as the high pressure system, and on the other side then would be the low pressure system. So we're running approximately 16 bar here in this example, but as I said, on the high pressure system we should be running approximately 10 to 15 bar of pressure on average outside temperatures, and on the low pressure side you should be running between 1.6 to 2.2 bar, so it's 25 to 30 psi on the low pressure side. So inside this thermal expansion valve is a very small hole, which is adjusted by a thermostat, like a wax thermostat effectively, inside there. But all you need to know is there's a small hole in there, and that changes the pressure from the high pressure side to the low pressure side. So at this particular point we can see we've got a liquid here. It's up at a high temperature. As this liquid is able to escape through the small hole, it then immediately turns into a gas, because effectively the liquid is able to boil immediately. So this boiling drops the temperature of the actual liquid itself, so it turns into a gas, vapor, and this is where your cold air comes from. So you can see here we're in a gas form. So our pressure's dropped to approximately 3 bar, and then the gas then passes through what's called the evaporator. Again, this looks similar to a radiator, like your coolant radiator, and the gas travels through here, and then your radiator, your heater fan will then blow the hot air from the outside over the evaporator, and which will then cool the air down as it then enters into the cabin. So that cold gas travels its way back to the compressor, where it starts the whole process over again. So the compressor will then compress that gas and turn that back into a high pressure and high temperature gas. It has to be a gas inside that compressor. We cannot compress a liquid, otherwise it will just damage the compressor. So that compresses that back into a high pressure, high temperature